Waterco Limited, based in Ruthin, North Wales, have been appointed by Alun Griffiths Contractors to help Anglesey Council assess and design a pilot natural flood management scheme. This presentation intends to illustrate how NFM solutions are used to reduce flood risk in the village of Dwyran. Anglesey Council have successfully secured funding from the Welsh Government, which is part of a national natural flood management initiative to identify suitable pilot sites in Wales, with the aim to improve understanding of the benefits and limitations associated with NFM as a means of flood alleviation. The village of Dwyran, Anglesey has been selected for this pilot scheme due to its flood history and localised flooding within the southern extent of the village. It is located off the south coastline of Anglesey. As shown on Natural Resource Wales flood map, the village is at risk from surface water, coastal and river influences. Natural Resource Wales are investigating a separate scheme to consider the flood risk from the Bund and Dwyran Valley main rivers. The existing drainage design comprises of a series of open channels fed by 2 springs and rainwater. During heavy rainfall, the water courses can become full. This problem is worsened during high tides as the open channels become tide-locked and water cannot leave the pond. As a result, the water backs up on the floodplain and increases the risk of internal flooding to properties nearby. The proposed scheme focuses on NFM solutions to capture surface water during tide-lock conditions and improve biodiversity in the long run. This will be followed by a 3-year monitoring phase using an array of catchment-specific monitoring devices. Due to climate change increasing flood risk and striving to rebalance the precious environmental surrounding, the NFM solution is an effective method to achieve these goals. Various other techniques were considered during the initial screening stage, such as trees for shelter planting and dams. However, due to the flat site, these were discounted in favour of ponds and wetland. A series of NFM interventions were considered. However, given the low-lying nature of the area and the specific problem, the wetlands and storage area offer the most viable solution. Further to this, informal discussions have been held with affected landowners who have expressed support for this proposal. As shown, here is a Google Earth image illustrating the proposed 4-pond solution and a simplified drawing of the site. In order to maximise water capture, the wetland area is to be surrounded on 3 sides with a substantial clay core bank. This will only rise 1 metre above the ground level, which will allow several thousand cubic metres of stormwater to be temporarily stored. Materials to build the bank will come from the existing field, which has a plentiful supply of good clay. The pond base will vary in depth to provide a habitat for a variety of aquatic wildlife. The maximum depth will be 1 metre, which is considered deep enough to prevent it being too heavily vegetated and to provide water depth for natural fish species to survive over winter. An important and relatively novel feature of the scheme will be to automatically control the pond outlet so as to optimise storage. As mentioned previously, flood risk is greatest when heavy rainfall coincides with a high tide. A sensor installed just downstream of the pond outlet will detect a rising water level and automatically shut a valve on the pond outlet pipe when a trigger level is reached. In this way, storage will only start to fill when most needed, providing the greatest flood risk reduction benefit. Once the water level subsides, the downstream sensor will send a signal to reopen the valve and the storage area will slowly drain down again. The temporary storage will return within a day or so to a pond surrounded by wetland. The storage area will generally be empty. If the water level rises downstream, it will trigger closure of the actuated valve on the outlet and the water level in the pond area will rise. Once the downstream level drops, the valve will reopen and the stored water will drain out. The operation of the pond will be monitored for at least 3 years after completion by instrumentation sending data by telemetry off-site. Analysis of this data will inform the storage control design such that a small diameter pipe or orifice plate could replace the automatic valve to provide a lower maintenance long-term control solution. The timeline for this scheme is based on an initial construction phase followed by 3 years monitoring phase. The long-term objective then is to create a natural pond surrounded by wetland, providing both flood risk reduction and an area of biodiversity. The planting scheme is to be implemented by Alun Griffiths Contractors with design and ecology advice. Waterco are grateful to Ynys Môn, Alun Griffiths and the Welsh Government for the opportunity to help create what will hopefully be a beneficial and sustainable asset to the local community.